All right, hello guys. I don't know if there's anything in particular that you guys would like to do. So you can indicate if there's anything in particular that you'd like to actually look at. But it must be maths related. Anything that you'd like to do or that you'd like to look at. Hello, Barky. Barakita. Yeah, but what specifically? If you're saying trig or circle geometry, there's a lot of things there. What about what in it? What would you like to? There's so many things there. You need to be specific with me. Aiden. Trig and its rules. Two-dimensional trig and its rules. Okay. If you want two-dimensional trig and its rules, just hang. But why do you want to do two-dimensional trig and its rules? Let me ask that. Why? Why specifically that, Aiden? Why Aidon? You find it confusing sometimes. All right. You want to prepare for term 3. Okay. Two-dimensional trig. Alright, so there's two things here that I just want to quickly look at. First things first. Right angled triangles. Okay, right angled triangles. To find the angles and sides in your right angle triangles, and I usually call them rats for short. Okay, so whenever we want to find the sides and the angles in a right angle triangle, okay, it's very basic, straightforward, to the point. We use so, ka, to, wa. It's as simple as that. So Aiden, do you know what SOHCAHTOA basically means, right? I don't need to explain that. Okay. for any right angle triangle to find missing angles and sides, you can use SOHCAHTOA. In other words, you can use the definitions of sine, cos, and tan, your basic trig definitions. So I'm sure you know them. Sine of theta is opposite of hypotenuse, cos is adjacent over hypotenuse, and then tan is opposite over adjacent. Okay, so no problem with that. Okay, so it's very easy, straightforward, that when you are given right angle triangles, all right, and those right angle triangles, like this one for instance, you can see most that this is a right angle. Okay, this is triangle BAC. You are given that is 40 degrees, that is 8, and that is x. And then I say to you, find the value of x. If we want to find the value of x, Aiden, here, how am I going to find the value of x? What do we do? You know, it's a right angle triangle, and I said to you to find the angles and sides in a right angle triangle, we use SOHCAHTOA. So Aiden, you are saying we can use sine 40. So sine of 40 degrees, sine of the given angle. In relation to this given angle, x is called your opposite side. So that is the O, the opposite side. And then 8 is your hypotenuse. Hence you use the trig ratio of what? Of sine. Then you want to find the value of x. This is x over 8. This is your denominator, your LCD, which is 8. You multiply by 8 both sides, which means, therefore, x is equal to 8 times sine of what? Of 40 degrees. You punch this into your calculator, you get a value of x, which is what? What's your value of x? 8 times sine 40. That gives you what? I'm waiting for people to tell me what 8 times sine 40 is. If not, then I'm gone. If no one can tell me what 8 times sine 40 is, I'm gone. Okay, very good. 5,14. Okay, and that's the length of a side, so it's not in degrees, but obviously this would be in units, right? But it's fine if we leave it as x is equal to 5,14, as long as we acknowledge that it's a length, it's not a angle, so we don't put degrees. Okay, all right, I'm just gonna do one more. Let's see if really and truly you comprehend. This is another one. This time round we want to find the missing angle theta, right? And in this right angle triangle we are given this 24 and this 16. So I want to find the angle theta. Can you find the angle theta for me? Okay, this is what you did in grade 10. So this is good revision, of course, for those for you. So okay, and the trig ratio that you use there, Aiden, I'm sure was sine theta is equal to 16 over 24, because in relation to this angle, this is the opposite, so hypotenuse. And then of course you would take the arc of sine on the other side, and then you'd use your calculator there to basically get your beautiful values, and there you would have it, that 41,81 degrees that you so beautifully recorded down there. Okay, I think you get the gist of the matter when it comes to the grade 10 concepts that were covered in earlier grades. Yeah, that was grade 10. All right, grade 10. Grade 11, all of a sudden, we are now exposed to non-right-angled triangles. In what? In grade 11. We're exposed to what? To non-right-angled triangles. So for your non-right-angled triangles, the SOHCAHTOA is not going to help you. Okay. So for instance, let's just say in the diagram, I'm just gonna look at an example here. Triangle DEF is drawn. And let's say it has angle E, which is equal to 41 degrees, angle F, which is equal to 63 degrees, and EF, which is equal to 2,5 units. Okay. This is your diagram that you have there. That's D, that's F, sorry, and then E is here. 41 degrees is there, 2,5 is there, 63 degrees is there, and we are required now to calculate the length. Calculate the length of DF. All right, and then follow that up with the area, maybe, of triangle DEF. Okay, now the honest reality is that, okay, had this been a right angle triangle, I would have simply used the what? The trig ratios, SOHCAHTOA. But because this is not a right angle triangle, it is a non-right angle triangle, and I want to find the length of DF, which is there. There is no hope in heaven of using your SOHCAHTOA. So that means I need to then look for an alternative way of finding the length of DF. And that is where the rules come into play. Our trigonometric rules for triangles come into play, because the question is, how am I going to solve that? So we are going to park this problem for now. We're gonna come back to it, okay? But we are going to park it for now. Okay. Yeah. So I'm going to now teach you the concepts that we can use. So we have 3 rules that we can use to solve non-right angle triangles. The first rule is called the sine rule. Okay. What is the sine rule? It is basically used to what? To determine an unknown length in a non-right angle triangle. It could be an unknown length or angle. Okay, which is not right angled, which is not a ret. But there are conditions to its use. Okay, this rule. There are conditions. I'm going to write down first what the rule is. So if I'm given triangle A, B, C, you need to understand the following. For sides that you want to find out or that you want to calculate, this is called side AB, side BC, and side AC. All right. Personally, I don't really like naming the sides according to the given angles personally, but I'm going to do it anyways. We call this side AB as small letter C because it's opposite the big angle C. So we label AB as small letter C. But me, I like retaining the AB, all right, for reasons that I'll explain later. Angle B is opposite side B, small letter b. Angle A is opposite side small letter a. So for the sides of for us to calculate an unknown side for a given triangle, the sine rule goes in the following way. We say side A over the sine of angle A is equal to side B over the sine of angle B, which is opposite that side, equal to side small letter c over the sine of angle C. All right. So this is a formula that we can utilize in order to solve for an unknown side. Okay. This is the sine rule. And this sine rule for grade 12s, writing June trial and final end of year exams, in the formula sheet you have this rule. It's there. So you don't have to know it off by heart as a grade 12 plan. But in grade 11, it just so happens that during your test series times in term 3, this may not necessarily be a rule given to you or written down for you. So you have to actually know it for now, okay, and utilize it correctly. For angles that I want to find, I can basically flip these fractions around and write the following. Sine of angle A over side A is equal to sine of angle B over side B is equal to sine of angle C over side C. Right? Obviously, we use only two fractions when solving. We use only two and equate only two of the fractions. So for instance, it's not like we're going to write all three equations whenever we are busy with a problem, but we will isolate maybe these two fractions and solve for whatever is missing, or solve these two, solve using these two ratios, or we can solve using these two, or solve using these two, or solve using these two. Okay, yeah. Now there are conditions when using this rule. Conditions, all right? And those conditions are very important. All right, so we are going to look at some examples so that you can see how the sine rule is used and how the sine rule can only be used in certain situations because a particular non-right angle triangle meets the conditions that warrant the rule's use. Okay. All right, so let me just give you a triangle here. All right, so that we can do an example and then you can see. And then from that, we can conclude what I had said. So we have triangle BAC, 26, 65 degrees, 67 degrees. Okay. Later, I don't know if I understand what you are asking, but you are more than welcome to guest request and I can accept your request and you can chat to me as to what are you actually asking. In the comment section as you are typing, I don't understand what your question is. What's the reason sine angles position? Okay, I don't quite understand what you are asking. All right, so here we are. We have BAC. This is the triangle. Okay, 65 degrees is this angle, 67 degrees is that angle, 26 is there. And what they are asking here is for us to find AB. Oh, okay, I hear you. All right, I'll answer that question very shortly. So, if we are asked to find AB, the first question you need to ask is, where is AB? Okay, obviously we need to have a good idea as to where what we want to find is. So where is AB? Here is AB. AB is located right there. It is the side that is opposite 67 degrees, which is an angle that we are given. So side AB is opposite 67 degrees, which is an angle that we are given. So we have a given angle, but we don't know its side that is opposite the given angle. But let's look at the rest of the triangle. We have BC, it's a given side, and we have an angle A, which is the angle opposite the given side. Okay, so I hope you guys see that from this scenario, the angle that has been given to us is opposite the side that we want. All right, so that means if we use the sine rule, we are going to say AB, which is the side we want to find. All right, and we are going to write underneath it sine of angle what? What is opposite AB? It's sine of angle what? Angle C. Then we are going to make that equal to, in this fraction we must have the information, all of it given to us, meaning we have to have a side opposite a given angle, and they have to be given to us, both of them. So if we look at this triangle, we have BC, which is a side. We are writing the sides at the top, so we write we write BC over what? Over the angle that is given, which is what? Sine of angles A. All right, yeah. So to begin, I write generally, then now I can substitute. Okay, right? So that's why I was saying to you guys initially that, we know that if we write angle A, this is small letter a. All right, so whether you say A over sine of angle A, and then you say small letter c over sine of angle C, is unimportant. What's important here is being able to identify a given. You want to utilize the side that you want that is opposite the angle that you've been given, and you can write that as a ratio equal to a given side with a given angle. So when you have a given side and a given angle, it means one of your fractions is already sorted out. So remember, we wanted AB. AB we don't have, but we have the angle that is opposite AB, which is 67 degrees. So we say sine of 67 degrees is equal to BC, which is what? 26 over what? Sine of angle A, which is sine of 65 degrees. Now pause here for a moment. I have used that formula where the side is on the top. The side is on the top, and I always said that we only equate two of the fractions, of course. So this fraction will have one thing missing, and the one thing missing is the one that we are looking for. The fraction that I write next must have a given side opposite a given angle, because the fraction won't be set up unless the side and its given angle are there. Alright, and since I want a side, it means sides on the top. That's very important. What you want, please write it on the top. What you want, write it on the top. And obviously for the second fraction, what we have for the side must be on the top, and it must be opposite a given angle. So the condition of using the sine rule is that you must have a side that is opposite a given angle, and they must both be given to you. That will help you set up your second fraction. Then for what you want to find, whether it's the angle or the side, the angle that you are looking for, which you don't know, must have its given side, or vice versa. All right, so that you can be able to do what? You can be able to solve. Now that we are here, all we do, guys, so simple, is we cross multiply the sine 67. So we say 27 times sine 67, and that's the beauty of having your unknown in the numerator, is that you can simply cross multiply and then punch into your calculator and get the answer. So AB, what is the value of AB, guys? Okay, I saw in the comment section Aiden had already gotten the answer, and he said it's 26,41 degrees. No, not degrees, right? And this is an error that students make all the time. They forget that in specific problems, we are solving a side here. So therefore, our answer should not be in degrees, and they make the mistake so many times. So AB should actually be 26,41 what? Units, because it is the length of a side. Okay, I don't know if there's any questions so far, but the sine rule is used when we have a side with a given angle that's opposite it given to us, and then for the side that we are looking for, the angle must be given, or vice versa. For the angle that we are looking for, the side must be given. Okay, so that's something you need to keep in mind. All right, now let's just say the question that followed had said find the side AC. Let's just go back to the original diagram as it stands and look, could we have been able to use the diagram with the information that is there to find AC? So we need to ask ourselves, where is AC? Now we can see here is AC. AC is opposite angle B. And the thing is, with the AC that we would be looking for, we don't have the angle. So that means our first priority then is that we need to find what this angle is. Can we find what this angle is? Is it possible to find what angle B is, so that if we have the angle, we can use the unknown side that we want with the unknown angle with the angle that we will have found that is given, and then use these two side and angle to basically set up our second fraction and then solve. Okay, so can we find what angle B is? Okay, so in triangle ABC, we can see that angle B is equal to what? It's going to be 180 minus 65 degrees minus the 67 degrees. Why? Interior angles of a triangle. Okay, yeah, angles in a triangle. So what's 180 minus 65 minus 67? What does that give us for angle B? Angle B is equal to okay. Then Having now 48 degrees, we can fill in our diagram. Do we have enough information to find AC? Do you see the angle? It's there for our unknown side that we want. Then we do have an angle and a side that is given, which will help us with our second fraction. Okay, so we can then go ahead and set up and say what do we want? AC over what? Sine of angle 48 degrees. So our first fraction, the one unknown that I want, is waiting to be found, equal to the second fraction must have information. So I'm going to use the side 26 with the angle opposite that side. So I'm going to write here 26, which is BC, over sine of angle 65 degrees. Then it's simple, guys. All you do is cross multiply. So 26 times sine of 48 degrees over sine of 65 degrees. Calculator, punch this in. 26 times sine 48 over sine of 65 degrees, and then I get a beautiful answer of 21,32 units. Okay, now remember, Mshibe, you could have, if you wanted to, you could take AB. You could take AB. I mean, that's still fine. But I was just using the diagram as it stood to try and see if is it possible for me to find AC without necessarily using the side AB. Now, you could use the side AB so that your second fraction is a setup of what? Of side AB with the angle 67 degrees. Your second fraction, the fraction that is on the side that will have all the information. And then you could then use AC and find the angle B. You would still be able to get the same answer. All right? Yeah. Okay. It will lead you to the same place. Okay, I hope that's clear. Right, so now since we are here in the area rule, in the sine rule, I want you to do this one for me. You've seen most how I did that one. Actually, sorry. I don't want you to do this one. I am going to just do one more here, okay? So that you guys can see. KLM 15, 25, 30. Okay, and they're saying calculate the size of, calculate angle K. Okay, so let's look at the diagram here. We have triangle KLM. We are given 30 degrees, the angle, with a given side opposite to it. So we are already safe because our second fraction will be safe to be set up. What do we want? Angle K. Where is angle K? Angle K is here. Who is he opposite? 25 units, which is the length. So I want what? Angle K. And since I want angle K this time round, I'm going to use the formula of sine, but for angles, which means in my numerator, I'm going to write sine of that specific angle at the top, at the left, so that it can help me solve for angle K. So I'm going to say sine of angle K. You see in the numerator, I'm no longer starting with the sides, but I'm starting with the angle, the sine of the angle. Over side who? Side K, which is LM. And guys, I just love using the angles with the actual given side. So I write LM is equal to what's given angle? Sine of angle M over LK, which is 15. So these are given to me. So my second fraction needs to always be sorted out. Sine of angle K, that's what I'm looking for. LM LM is equal to 25. Sine of angle M, I have sine of 30 over what? LK, okay, which is basically 15. Now I am ready to do what? To just cross multiply. So that means 25 times sine of 30 degrees over what? Over 15. Sine of angle K is that. Then I can grab my calculator and punch in 25 times what? Sine 30, sine of 30, close the bracket, over what? Over 15. Then I get my answer, 5 over 6. But remember, I'm not done yet. This is just sine of angle K, which is equal to 5 over 6. If I want the angle, I'm going to say angle K, take arctan on the other, arcsine on the other side. Inverse of sine 5 over 6. So I go to my calculator back there, it's 5 over 6, that's an answer that's there. All I'm going to do is simply say sine, oh my goodness. Okay, that was not supposed to happen. Okay, so let's just say shift. That's the inverse of what? 5 over 6, 5 over 6, close. Then what do I get? 56, so angle K is 56,44 degrees. And that's that. 56,44 degrees. Okay, right. Then, so what I've just done here is I've actually done questions on the sine rule, and I've looked at both scenarios. The scenario where I'm being asked to find a side that is not known to me, but the side does have an angle, which means my fraction that I will write at first is going to have at least a piece of information so that I can just find the unknown. Then my second fraction, it must definitely have both the angle and the side given to me. That is the condition. I have to have a side and an angle given to me in order to use the sine rule, and I have to have the one angle that is opposite either the side that I'm looking for or the one side that is opposite the angle that I'm looking for. That is the condition of using the sine rule. It does not work in any other way. Thank you so much, Michelle Stephen. I really appreciate the gift, the rose. It's very much appreciated. Okay, so I hope that makes sense, guys, and that you are kind of like getting the flow of when we use the sine rule and under what conditions we use the sine rule and what needs to be intact in order for us to use the sine rule, and why it is that sometimes we use the sine rule with the side lengths in the numerator, right? And why it is that sometimes we use the sine rule with the angles in the numerator, or sine of the angles in the numerator. And then of course the simplicity in making sure that your unknown that you want is on the left at the top, so that you can simply cross multiply. Whether your unknown that you are wanting to find is on the left at the top, so that we can simply cross multiply and get the answer. Makes life so easy. Okay, so guys, all right, here's some what you might call, they call them exercises for you, right? You can do these just to check yourself if you are good and if you have gotten the concept, okay? Because it's important. I've seen that sometimes when I teach in these live sessions, people see that I am good and I can do it. But I often wonder, and I'm like, if people are simply going to leave these live sessions having seen how good I am, when will they ever actually get the understanding for themselves? and see how good they are. Okay. Okay, we need to find x here, guys. For this triangle, the unknown is a side. For this triangle, the unknown is an angle. This triangle, non-right angled. This triangle is also non-right angled. So therefore, it means that I need to apply an appropriate rule. Okay, and we're still just looking at problems under the banner of the sine rule. So I'm going to write the first, second, and third. And then, yeah, I think at least for the sine rule, that should be enough. So that I can roll over and do the next rule, so that you guys can see what the next rule has to bring to the table, and why it's different, and how it is able to deal with problems that do not meet the condition of the sine rule. Okay, there we have it. There we have it. Okay, so there we have it, guys. Those are the 3 problems that you can attempt, and in each situation you just need to find the value of x, okay, using the rule that we've just learned. Okay. Okay, do you guys want me to go on? Do you want time to do these? Do you want me to move on, go to the next, or are you guys wanting to just have time to do these? Just let me know in the comment section what you guys would most prefer or better prefer. Thank you so much, Michelle Steven. Michelle Steven is like helping mobilize the masses to tap and share and do all that stuff. So thanks. I think I need to make you my moderator, Michelle, don't you think? Okay, move on. Aiden has spoken. Aiden is the one that basically asked for this. So if Aiden says we must go, then we must go. Okay, so then the next rule is called the cosine rule. This is a rule that we also use to find sides and angles, slightly with a different condition. Find sides and angles, okay, in a non-right angle triangle. We use this rule as well. And the rule goes as follows, guys. If you have a triangle, and let's say it's triangle ABC, and let's say the unknown angle is A. We don't know angle A. All right, we don't know angle A, okay, but in the midst of not knowing angle A, side A is given to us, side C is given to us, and side B is also given to us. All right, the formula that is used is, since we don't know angle A, we are going to say A squared, all right, is equal to B squared plus C squared. Kind of resembles something that we refer to as the Pythagoras theorem. A squared is equal to B squared plus C squared. minus 2b times c times cos of the angle opposite the side that we began with. So this angle A is always opposite the side that we write as the subject of the formula here. At least the subject squared. So A squared is equal to B squared plus C squared minus 2 times what? This B and this C. So whatever we wrote here is what we 2 times here. And then we multiply by the angle opposite this side, which is cos of angle A. So that's why I said that's if A, we don't know what it is. What if we have the same triangle, but this time round, B is the one that's unknown? Then it means the formula changes as such as well. So B, C, A, opposite angle C, we have a small letter C. Opposite angle B, you have small letter B. And opposite angle A, we have small letter A. So if B is unknown, then we say small letter B squared is equal to A squared plus C squared minus 2AC cos of angle B. So the angle is opposite the side that starts as the subject squared. Then the other sides, the sum of the square of the other two sides minus the product of the other two sides with 2, negative 2. So that is the formula that we can use if it is angle B that we don't particularly know how to find. And lastly, the same, but it's just that it's C this time round that is not known. So if angle C is unknown, then what we would do there is do what? We would say C squared is equal to A squared plus B squared minus 2AB cos of angle C. Yeah, so the angle is the included angle. That's very important. The sides are basically, the angle is sandwiched in between the two sides that make that angle included. So the included angle has the sides that we basically write as the sum of the square of those sides. Okay, minus 2 times the product of those sides, and then cos of angle C. So 3 conditions. Conditions that we use. Conditions of use of the cosine rule. It's simple. If all 3 sides are given, and no angle, and we want the angle, we can use the rule. Okay. Or it could be that you are given 2 sides and an included angle. Then you can use the cosine rule. So let's look at examples so that you guys can appreciate what we mean by that. Let's say we have a triangle like this, where this is 130 degrees, that is 25, that is 30, and that's BAC. Okay. So just remember, what did we say are the conditions of use of the cosine rule? All 3 sides must be given. Okay, all 3 sides. In this situation, this is 25, this is 30, the third side is not given. So you would think that this condition doesn't fly, so therefore we can't use the cosine rule. Let's move on to the second condition. Two sides and included angle. Two sides and included angle. That will help me find the side that is opposite that included angle, which is BC. Okay. So if they say then find BC, okay, then it would be quite straightforward. If we go back to the rule, remember that the side we are looking for is the subject squared, which is then equal to what? AB squared plus AC squared. So we are squaring the sum of the other two sides. BC is already identified. Okay. Then minus 2 to what? 2AB times AC. Cos of what? Angle. It's cos of 130 degrees. Okay. Then we go ahead and substitute. BC, AB is 25 squared. AC is equal to 30 squared. Minus 2 times AB, 25 times 30. Cos what? Cos 130. Then you punch this all into the calculator, guys, all of it. I'm just going to do that very quickly so that we can appreciate the value that we get. 25 squared plus 30 squared minus 2 times 25 times 30 times cos 130, close the bracket, 130, close the bracket, equal. Okay, I doubt that that's the answer. It may appear that I did something wrong, so let's just retype. So that's 25, and that is squared. So AB squared plus AC squared. Or maybe I'll make that length a bit longer than it should have. Okay, maybe not. Plus 30 squared minus 2.25. So not 2.25. What did I say there? It's 2 times. So it's 2 times 25 times 30. Times cos 130, close. There it is, 2,489. So it was 2,489. So I write down that 2,489, all of it, comma 181,415, because I can't yet I can't yet round off. I'll round off at the end. So then that means the square root of the answer is equal 49,89. 49,89. That is the length of BC. So guys, you see here, you couldn't have been able to use the sine rule. Why can't we use the sine rule? Because we don't have a side that is opposite a given angle that we know for sure. Because we need to have that in order to set up a second fraction that has already got values. Here in this situation, we really do have two sides and one included angle. So therefore, if we have two sides and one included angle, it means we use this cosine rule. No problem. No problem. No problem. Okay, no problem. Okay, I just wanna, so you see here this condition worked. Okay, let's look at another situation so that we can make sure that all conditions with all situations are taken care of. Let's say we had 50 meters, 30 meters, and 59 meters. This is DEF. And what they are saying is determine the size. Determine the size of angle D. Okay, determine the size of angle D. Where's angle D? There's angle D. Now I need to determine the size of angle D. So in order to determine the size of angle D, what do I do, guys? It's very simple, right? First and foremost, you see the conditions of use of the cosine rule is that all three sides must be given, right? And in that instance, no angle. So all three sides have been given. And what am I wanting? The size of angle D. Okay, so what I'm going to do is I'm going to look, angle D is opposite side who? Side EF. So that means I'm going to make EF squared the subject. Then I'm going to say EF squared is equal to ED squared plus DF squared minus 2 ED times DF cos what? Cos of angle. The angle opposite 59, which is EF, is actually cos of D. Angle D is what we want to find. So EF squared was EF, it's 59, is equal to ED, 50 squared, DF, 30 squared, 2 times ED, 50, times DF, 30. Cos what? Cos of angle D. So now at this stage, hi guys, at this stage, I can say 59 squared minus 50 squared minus 30 squared is equal to negative 2 times 50 times 30 times cos of angle D. Then I'll divide both sides. Divide both sides by what? By negative 2 times 50 times 30. Okay, so I'm going to have 59 squared minus 50 squared minus 30 squared over negative 2 times 50 times 30. Okay, is equal to what? Is equal to cos of angle D. So I grab my calculator, I punch all of this in. You guys let me know what you get. Grab my calculator, punch all of this in there. Grab my calculator, punch all of this in there. What do you guys get? You tell me. You tell me. You tell me. You guys tell me. Negative 0. Okay, therefore cos of angle D is equal to negative 0,027. Okay, and then after getting that, cos of inverse. Now there are two things here, important two things. Cos is negative in one of two quadrants, that one and that one. So there's definitely not going to be a situation where I'm going to actually, you know, so yeah, sorry guys, I need to find here the reference angle. So this is RA, cos of inverse. I'm just going to assume the positive because the negative sign is taking care of my quadrant. So my reference angle of this gives me what? So I'm trusting that you guys' answer is fine. Okay, at 88, right? And then from there, that's my reference angle. So I'm going to subtract. To get angle D, I'm going to subtract 180 minus that reference angle. Okay, which is angle D, 180 minus that 88, comma. But I write down the entire thing, the entire decimal. Okay, everything, right? It's 180 minus that entire decimal, not rounded off. So then angle D is going to be equal to, okay, it's 91,5. This 7 says what to the 4? It says go up. Okay, 2 decimal places, so it's 91,55 degrees. Okay, so reference angle, I get the cos of inverse. I get that angle, that reference angle, like I said, is 88, comma, that long answer that you got, guys, 88, comma, something, something, something. So I just write dots there. Then I just subtract this from 180 so that I can get the actual angle, which is 91,55 degrees. So now you've seen the cosine rule at work. The cosine rule can be used when you have two sides and an included angle. Remember, guys, an included angle is the angle that is sandwiched in between two sides. Two sides that sandwich an angle, that angle that is sandwiched is called the included angle. Okay, don't forget that. So that is one of the conditions, two sides and included angle. What does that help me find? It helps me find the side opposite the included angle, which I make the subject and solve, no problem. Then there's a situation when there is 3 sides given, no angle at all. 3 sides given, no angle at all. I'm asked to determine one of the sides. Then of course I'm going to identify the side that is opposite that given angle, make it the subject, square it, square the other sides, subtract 2 times the other 2 sides, cos of that angle that I am looking for that's included. And then, guys, algebraic manipulation. If you have a negative numerical value, that just means you find the reference angle, checking out things in the second quadrant, you subtract that reference angle from 180 so that you can get your answer, which is 91,55 degrees in this situation. So I hope you see the 2 conditions. In these conditions, the sine rule cannot be used. In these conditions, only the cosine rule can be used. Okay, I hope we are good. I hope we are well. That is what we call the cosine rule. All right, and of course, as usual, there are activities which you can do to just make sure that you reiterate that rule. Okay, just make sure you reiterate the rule, and so that you are fine, sorted. Okay, so I'm just gonna write 2 problems for this one. Okay, that's one. And then the second one is this one. That's the one. That's one. Okay, and then $30, $45, $22. Want the value of x there. Okay, so in both cases, we want to find x, find x, find x. And please take note the condition where this rule can be utilized. The last rule I'm going to look at, guys, is the area rule. Okay, and I'm gonna hold it right there, guys, because I need to really, I've been up. The last rule is called the area rule. This rule is used, it's used to find the area of a triangle where there's no perpendicular height, right? But the condition of use for this area rule is that you have to have two sides and an included angle. That is the condition that works for area rule. So it should be pretty straightforward. The area rule only works if you have two sides, and an included angle. This is the included angle. Okay. Yeah, I will. Okay, I'm gonna finish off actually with this rule, then I'm gonna do more the next time, okay, for you grade 11s. So yeah, if we have triangle ABC, then of course angle C we have, right, and we have the A, we have B, it's given to us. Okay, two sides and an included angle means we can use the area rule. We find the area of the triangle, the area of the entire triangle using this rule. Helps a lot. Okay, so I'm going to do an example so that you can see the rule at use. And then I have to call it a night, y'all. So if we look at this triangle ABC, the question says find the area of the triangle ABC. What do? We want to find the area of the triangle ABC. So if we want to find the area of the triangle ABC, then we can. It's really that simple. The question is, do we have two sides and an included angle? Do we? This is two sides. Is 30 degrees an included angle? Is it? Because if these are two sides and this is the included angle, in other words, the angle is sandwiched in between the two sides, then we can go ahead and use the area rule and solve. Because what will the area rule say? The area of triangle ABC is simply this. Half of what? The product of the two sides that sandwich the angle. So the product of what? The product of AB times AC. Then the sine of angle what? Angle A. Because A is the included angle. So the sine of angle A. So we're going to say half AB. What's AB? 6 AC. 8 sine of angle A, sine of 30 degrees. And all you do is you punch all of this into a calculator. Don't waste any time. Okay, so 0.5, 0.5, which is half. We times that by 6, we times that by 8, we times that by sine of 30 equal 12. So the area of the triangle is 12 units squared. Okay, 12 units squared. That's the area of triangle ABC. Don't forget the measure, the unit measure for area. Okay. All right, I'm going to hold it right there, guys. That was an example for area rule, and of course, problems galore. I think obviously, guys, we can get those. Okay, classwork, homework. So you have a bit now that you can do until we meet next time. Determine area of triangle ABC. So 1, Okay. And I guess the famous $1,000,000 question, do we have an included angle? Yes, we do. Do we have two other sides? Yes, we do. Are they the ones that sandwich the angle? Yes, they do. Can we then solve for the area? Yes, we can, you know. So this is like the thought process that you have to go through. So all of this is determine the area, also here determine. Okay, that's the last question. Let me just redraw this diagram because it's too small. So here we are given a problem. If area is 8,45 centimeters squared, then of course determine the value of x. Okay, to those that asked the question and you are now busy with the work and maybe there's a little bit better understanding of the subject matter, and you previously just needed a little bit of an oomph, maybe you're doing self-study and it's gotten better, please let me know, guys, in the comment section, because remember, as I do this, I don't often know, okay? I don't often know what's happening. Aiden, you're kidding me, really? Oh, wow. Well done, bro. Well done. Sure. 93%. You keep that up. You keep on killing it, buddy. Wow. I'm so impressed. That's very impressive. 93%. Ah, you must keep it going, Baba. Must keep it going, please. Keep it flowing. Keep it flowing. Like the water. Yeah, keep it flowing. So you haven't gotten your results for term 2 then, hey? Yeah, so these are just basic, you know, just to get you into the rule and the procedure. Area rule, sine rule, and cosine rule questions tend to get a bit more complex, and maybe in my next live session with you grade 11s, then I'll be able to showcase some of the other complex problems, and also furthermore, I'll be able to prove the rules, because sometimes you are required to prove the area rule, to prove the sine rule, to prove the 3 rules that you have. So I'm going to prove those rules the next time I have a live session, and we'll look at variable type questions as well. Besides the numerical numerical type questions where you are asked, look at complex problems as well, where they stack triangles on top of each other, and you have to actually find your way out and find the missing side, sometimes find the area within that diagram, and so it goes and so it goes. So we'll look at those things, and also your variable type questions where they ask you to prove, you know, and so forth. But thank you, guys. Thank you so much. Thank you for the taps and the likes and the heart and the roses as well. We basically reached 7.2k likes, you know, so that's fine. You can predict for paper 1 and a perfect score for paper 2. Oh wow, sure. Aiden, you don't mess around, do you? Well, that's amazing, bro. That's really amazing. I'm really impressed. This is impressive, you know. Hopefully you can get a perfect score in term 3 and then equalize on making sure that you get a perfect score end of the year. It's very possible, man. These are possible things. These are possible great things. This was grade 11. My dearest girl, sorry for not answering you. Yeah, Shugi. I'm sorry about not answering you there. Yeah, I see you proudly, Tsonga. Yeah, thank you so much though for joining in. Aiden, keep it up, buddy. Keep it up. This is good. This is good. Alright, guys, thank you. I'm going to have to love and leave you. I'm spent. I'm truly spent. You could swear I'm getting paid for doing this, but nope. But yeah, it's definitely for the love and also just for the progress of those that join my lives. That's very important. Otherwise, let me love and leave you. I'll see you again, and thank you for joining in. Maths is a game. Let's play. Aiden, are you off to study physics? Okay, that's no problem, buddy. Cheers. Thanks for joining. Bye. Yeah.